stop abruptly because we had that pakoda thing. So what were the questions in case anyone can recall? Fine. So what I believe is, uh, you guys know what are the different colors that we are having. Guidance radio waves. Yep. We were discussing that. That was this was a question on that twisted pair. So we let us write down all the colors that we might be having. So you can check it out from here, and we can write it down. So one would be blue. Next would be blue white. So that is one pair. The other pair would be orange, and the other would be orange white. The next would be green, and green white. Next, we would be having brown and brown white. So this is the combination that you would be getting whenever you prick one of them. Now, our question comes in what is the kind of signals we are sharing over each of these. So in case we talk about orange and orange white, it is used to receive and send data. Data signals are transmitted and received over it. Orange. In case we talk about data reception, in case we talk about green, data is sent over this pair. The other pair that we are using here, the orange white would be the reference signal for data reception, and this green white would be for data sending. It would be the uh, mm, mm, reference signal for my uh, data sending. I hope that was clear to everyone. Now, in case we are talking about blue and brown, they might be mm, uh, other signals in case we need, or they might work on reference signals. Uh, again, in case we talk about green, we have talked already about. So brown is normally, in case we try to understand, this is normally unused, and this might be in case we come up with some other new signal that might be it would be used in the future. That was left In case we need, we might go for its usage. Now then it brings us to the blue, that is also that also remains unused as of now, but they have left it unused. In case over time period, if we want, we might use it for voice signal in case it is needed. Reference for data reception, reference for data transmission. So in the future, when we came up with this standard, uh, uh, the standard for this, they came up like we are right now sending data, we are receiving data. In case in future we also work on voice transmission over this, so we can use one for blue might be used for voice reception, and this might be used for voice transmission. And likewise, that is what the standard was developed, but we never needed that, so right now they are unused. So I hope that answers one of the questions that you guys had yesterday. uh yep, transmission, reception, so that is what we have. Yeah. So these are the standards that we have, and those standards, many of when we are talking about many of these standards, they are left so that we can come up with something in the future. So that is what we have for shielded and unshielded pairs. So both behave in the same manner, no difference. Now, any other question in case anyone has? That might be taken to be one of the references. This is really something which I was looking for, but I did not find. Fine. So, any other question we might have? Fine. So, let us discuss a little of the theoretical part that we are having here. So, let us discuss them all. So, the first we talked about was our coaxial cable. I believe we are we discussed on almost all of the transmission media. So, yep, we are almost discussed with everything. Okay. So let us discuss the theoretical part that we might need to learn. Or the first thing about these coaxial cable is you have copper as the conductor. Copper conduction is used. Why copper? Because copper is not only cheaper than silver, but it also is a very good conductor. Then you would be having above this, you would be having a protective layer, that would be plastic protective layer. Then you would be having a noise cancellation layer, that was sorry, protective layer. Then we saw we had this, where it is. Hmm. We saw that image where we had that noise cancellation layer, the mesh we had, and above that mesh you had another insulation. So that is how it was. insulation. So that is how we make the coaxial cable, and that is what we have already discussed. Now, getting back, what are its advantages? So we can have up to 10 Mbps transmission rate. That is what the standard is. But at times we have got more than that. Uh, that is at times. Coaxial cables, they are very easy to when we talk about the maintenance, that is really easy and that is not troublesome as compared to our fiber optics or other media. It is maintenance low, and the best part is you can use it for very long distances because it won't break. You cannot think of any physical damage that normally does not happen, so you can use it for long distance communication. And this speed that we are getting, 10 mbps, that is really a good speed when we are talking about before what we had with this OFC. That was really good. So that is our coaxial cables. Now we have our twisted pair. So we have this UTP, the untwisted pair. So in case we are talking about untwisted pair, the range is a little low. Uh, a little low. So it can go up to 100 meters. That is the official standard. But it is not like you can get only up to 100 meters. You might increase or decrease a little. And the major usage is the LAN. And in case we talk about our coaxial cables, they are used for televisions, they are used in BTS, and might be we can use it for other places as well. So that is our UTP. Then we unshielded twisted pair. This was our unshielded twisted pair. Then we can have our shielded twisted pair. In case we talk about shielded twisted pair, uh, things would almost be the same. Now, since it is shielded and it allows you a lot of noise cancellation, that is why we can use it for even a longer distance. Longer distances possible for shielded twisted pair. Because of the noise cancellation property that it has, and with this noise cancellation property, we mean our the here like the yeah, the protective layer, metallic layer that we are having, that is our shield and that is our noise cancellation. So it can be like be more reliable as compared to our UTP. Since again, when we are talking about a very long distance, a lot of noise signal might try to creep in. So UTP, you are not using it for more than 100 meters. That even in 100 meters, we are getting any interference. That interference would be really low. But when we are talking about kilometers, then the interference would make a lot of problems. That will creep in a lot of interference. That would be problematic. But in case we are talking about shielded twisted pair, you can have it for a kilometer, and every noise signal that is trying to creep in, that won't make any difference. So it is reliable and it can be used for longer distances. The usage for both would be almost the same. LAN cables, that is where we are using it. I hope. Then we have the OFC. Now I hope you guys know about the OFC, that throughout the world we are using OFC for yeah, for most of the kinds of data transmission. So in case we talk about, so it provides you a very fast speed, then very long distance. That distance cannot be defined. Uh, it is covering the world. Even we from Europe. Europe is connected to Asia via those OFCs only. Reliable and faster than almost all the medium. Almost all the medium. Then again, since we are transmitting uh, light in form of electric pulses, yeah, not electric pulses, but light pulses, and that is within a sheath, it means we cannot have any interference. So no noise. Since we have no noise or no interference. Now, noise, it is a term that is quite new to you. So let us call it interference, which I believe you guys understand what interference is. When we have a wire which is conducting electricity, and we are creating, yeah, like we are creating a magnetic or electric field right outside it, then we might see that there is a fluctuation. So that fluctuation is my interference or noise. So since we have no noise, no interference, it is much reliable than any other form of communication. Uh, it is very lightweight, but the problem is very lightweight. But the problem is it is costly and can get damaged easily. I hope that was clear to everyone. In case anyone has any questions, you guys might even go through the manual and check out in case. Plus, what? Yeah, Ashok, what do we mean by this plus? Can you please help us know? Plus low power loss. Yes, almost negligible losses. Uh, Negligible losses. Again, since we are talking about wires, so wire has some kind of resistance, but light within within a medium that is not providing you with any kind of refraction, yeah, like any kind of refraction or reflection that is tending to block, it would be working very well. So we also saw how this OFC is being cut and pasted. Now we saw that we are cleaning it. The cleaning is done so that not even a small microscopic material even gets into the fiber. So these are the different benefits. Now, in case anyone has any question, please let me know. In case no one has, just that would be fine. Then let us get to our, in case anyone has. So you guys can write down whenever you have a problem or you have a question. And even if you feel that I need to stop, just unmute yourself and just talk so that we can stop there and then take your question right over there. So just don't be shy. It is for you only. So don't be shy. Whenever you feel the need, just let me know. We can take that question orally as well. So then let us come to our microwaves. We discussed what microwave is like. Uh, and in case we talk, one more thing that we need to talk about. So most of the data transfer, data transmission that we are seeing today is via OFC. Now, in case we talk about microwave signals, so mobile telephony, that is the major use. Then we mm, another is it does not need it can pass through yeah, pass through many of yeah, many things like we can have it can pass through glass, it can pass through uh, small walls, so it can pass through certain media, and in certain media it cannot penetrate, but normally it can allow you uh, a lot of things. It can pass through, it can penetrate. So that is what we have. It can pass through various mediums or obstacles. Then it can be used for transmission up to 20 kilometers was what we saw yesterday. 20 or 30 kilometers we saw yesterday. So that is again which we where we can use. And maintenance cost is very low, though maintenance is low. Now they have started writing maintenance with an E. Maintenance is low. So these are the features of microwave. Now, in case we talk about those radio waves that we talked about. So radio waves are mostly used for, I believe, about TVs, radios, or we can say multicasting and broadcasting. Multicasting and broadcasting kind of thing, communication. So these are the different usage. They can penetrate those medium or those obstacles which is not allowed for microwaves. So they can pass through, and again it can be transferred to 30 kilometers is again one of the ranges that we can have for our radio waves. So that is what, and maintenance again is very low. Even operational cost is low. That is why it is very popular. Operational cost and maintenance is easy. Maintenance is low. Okay, I made this mistake. Uh, mm, any questions from anyone? Now, we have one more thing, that is my satellite communication. Now, in case we talk about satellite communication, we have not discussed. So let us try to understand satellite communication, and let us go for an image. Now, this is what we are having. Now, you have an uplink where you are transmitting your signals to the satellite, and this satellite in turn is sending it back to another downlink station. Right. So we have Earth stations that are being connected. Again, this is our complete medium. So let us take this copy image and let us paste it here so that we can discuss this. So Now we have ourselves as the users, and we via various media we send these signals to the antennas, and those antennas are sending it to uh, us, the satellite which is meant for that. And this satellite is doing nothing but reflecting those signals back to another station, making the communication from this antenna to this antenna free of anything like we have this line of sight or any other uh, features that we might need that is not needed because of this satellites. Now, satellites, in case we talk about satellites, in case we talk about satellites, satellites can work on radio signals, they might work on microwave signals, they can help the different signals. They can be used to carry data signals, transfer data signals. They might transfer digital signals. They might even help you with your analog signals. So, whatever type of signal you are trying to transmit, you might use the satellite communication. Uh, it might be used for data, for audio, for video, or any kind of signal. So, I hope that was somewhat clearer to you. So wherever we are facing the trouble of line of sight communication, we cannot go for it. We have those satellites to help us. Now, it is said that we are having more than 1800 satellites which are solely used for communication purposes. So 1800 satellites plus is what the number, and we are increasing this number day by day. So that is what we have for satellite communication. Now, any questions on any of these things that we discussed? No, fine. In case we don't have any questions, what we can do is we can talk about the different tools that we would be using for various purposes. But please, guys, first confirm in case we can move ahead or we need more discussion about the topic that we were doing right now. Are you guys still there? You guys can hear me? Was like 10 minutes back, Rakesh said something. After that, no one has said anything. Guys, you can hear me fine. So I hope that was clearer to everyone. Now, in case anyone, what is ISDN? Now, can you help me know where you heard this ISDN? So I hope ISDN would be something which we would be covering. Uh, so let me try to. Yep, that was Pooja. I don't know. Yes, Pooja, where did you hear this ISDN? Uh, or in case that is fine, that is Integrated Services Digital Network. That is really good. So this is a better to say it is a protocol, or this is an standard that we developed for this transmission. We right before we came up with this, we had those. How it works? Yep. We are coming to that. I just wanted to know how much you know about it. So you must have heard about those telephone exchanges, right? We had previously we had those circuit switched telephone networks, telephone exchanges. So the problem that we started facing with these telephone exchanges was it could only transmit analog it could only be used for transmission of voice signals. It could not carry data. Only voice signals could be transmitted over those circuit switch telephone exchanges. So we came up with another standard that was ISDN, or that was a standard, that was a protocol that was used for mhm, like voice and data both. And we have something called full duplex transmission, where what happens is simultaneously you can transmit and receive data, simultaneously you can transmit and receive voice. uh, I hope that would be somewhere in our syllabus at a later stage. uh, yeah, half duplex, full duplex, simplex. We can have three modes of communication. So we had like previous telephone exchanges, we had simplex, where transmission lines had to be created, and that was really a troublesome thing. That was followed by half duplex, and then came our full duplex, where simultaneously data signals or voice signals could be sent and received. That was followed by ISDN. Since we came up with data signals also in 19 late in the early in the 1980s, we had it started to send data. So it was like that. Now, in case we talk about the block diagram, uh, so so let me draw a block diagram since she asked like how it works. Now suppose I have not a mobile phone. This transmission system, let us go for a computer. Then let us go for a mobile, for a telephone. Now suppose this is a telephone, the old one. This was used in this ISDN protocol was used in our telephone exchanges. So that is another telephone. Let us think of this as another telephone. Now, what we had was we had those ISDN exchanges. Your data signals are received by this ISDN. Your voice signals are received by this ISDN. Another voice signal is being received by this ISDN. Now, what it does is it works on packet switching. So it converts all that data into packets. Now, obviously, we would be very soon learning about those packets. Those packets contain the uh, like senders and the receiver's address. So it converts it into packets and creates a full duplex transmission medium between the other. And now this is being sent over a media. That media can be our coaxial cable. So this is what you are having. This is these packets are being used transmitted over a medium. And now this this is your exchange. Exchange at transmitters, like exchange one. And here you have ISDN protocol for exchange 2. I am calling it EI2. Let us have it exchange 2. Now we have two phones. So we need to have two phones here also. Since each phone has to be connected with a phone. Now suppose we are connecting that with a computer as well. Now we can have one more phone that is needed, and we can have a server here. Let us take to this to be a server. Sorry, I am very bad at drawing. And let us have it as a computer. So this was how ISDN worked. It could transmit uh, data signals. It could transmit voice signals, transmit and receive both simultaneously. It could send multiple data signals, multiple voice signals at the same time and receive them also. So this is how it worked. Pooja, do we need more details, or that is for the beginner? I would think of it like that is fine. Since again we need to learn a few more things about packet switching a little before moving ahead to understand this more clearly. So our next topic takes us to no. Anyone having any other question? Just let me know. We can take that as well. Now that might be outside. This ISDN was as of now not in our in our syllabus. I believe we are not even studying it in colleges. We have left it also. Ah no, Pooja, that is fine. You don't need to be like that. Now, anyone else is having any other question? We might take. And it is really good that you are coming up with questions. That means you are there, you are attentive. At times when I don't find anything, no one is saying anything for a long time, that is something troublesome. And one more thing I should tell you is this like previous exchanges, they allowed you private lines as well. So it would help you with private lines also. Now, suppose you are using a hotline to connect. Now, I believe you guys must have directly to they used to connect directly through a secure line to another head of the state of another country. So that is what we had. So we can also have, besides those packets and those switches, we could also work on a private line on this ISDN network as well. So that was also possible. So any questions in case we have? Fine, great. So this takes us to our tools, a few tools that we would be talking about. The first is the crimping tool, and this would be one of the most important tools that we would be using for our practicals. Now, this is how a crimping tool looks like. So uh, a very good image is what I wanted. Hmm, what? No, does anyone know anything about crimping tool? Have you ever seen it, or has anyone ever used it? That is fine. That is fine. We are using it for. Okay, good. For Pooja, you have used it. Mm, so Pooja, you like what was the course that you took before joining ADIT? Were you into computers? Wow, great. So Pooja knows a lot of these things. So Pooja would be an ideal person to refer to. Now, mm, mm, this is the worst thing I have seen. No, Microsoft, I am really messed up. Now we are using mm, a crimping tool to create our LAN cables. Now LAN cables, we are calling it UTP, STP, or we are calling it RJ45. So we are giving it a lot of names. So this is how a cable looks like normally, and we would be talking about uh, these would be done at a later stage when practicals would be done. So let to see. No, we so yeah, yes, this is what we have already have. Now this is our LAN cable. We are using either UTP or STP for creating our LAN cables, and we are using those crimping tools on this to create our cables. The first thing that we need to do is we need to remove this outer layer, right, Pooja? And for that, we have this cutter. You can see we have this cutter, right, Pooja? Since Pooja has done it, so now what I wanted to tell is we create mm, we use those crimping tools to create our LAN cable. All right, RJ45 cables or IJ45 connectors. That is the use. Uh, Now, this it can either be UTP, this one, this is our UTP, and this is our STP. So it can be either used on either to create our. Now the first thing that we need to do is we need to cut this outer covering that might be like that is the outer covering. So that outer covering needs to be cut down, and for cutting that we use this blade, right, Pooja? Yep. UTP, STP can also be used. That depends. Cat 5, Cat 6. Yes. It can be used for multiple things, but we would be talking more about RJ45. So that is the first thing we do is we need to remove the outer covering. That would be followed by bringing all these cables, like open up, have the exact color pair that we need to have. And once everything is opened up, untwist it, untwist all these, bring it to the same level. And once it is brought to the same level, you need to cut it so that every wire is of the same length. That is our second step. Separate all cables, bring it to the same layer, and then cut it to bring it to the same size. And once you have those, you have all, yeah, cut it to the same length, have match color coding, color combination, then cut it to the same length. And once you have it in the same length, you need to have that RJ45 connector, since that is what we would be using. Once you have this connector, this is how this connector looks like. There is a provision here. You here you fill in and then use this head. Once you have like mm, put the wires in the provision in this RJ45 connector, you use this head to do the crimping or make the final connection and crimp it. Make the final connection. Now, when you see here, you can find metallic connectors. Now, this would fit into your computer and this will allow the data transfer. So this is how it works. Now, let me show you a video for those. You very small video is what I wanted to show you. Fine. So let us try to 8 then. So let me share this video for those who have not worked on it. So they might check this out. I will try to share this in your groups as well. So that is how we do. I hope very soon we will be doing this. Uh, yeah, like practically. Yeah. This is how you create a straight through or a crossover. A straight through is done when you need to connect uh, unmatching devices. Like different devices, you go for a straight through, and in case it is similar device, you go for a crossover. So this is transmission one, that is transmission like minus, like that is the reference. So you have this receiver one, and you have the receiver minus, means the reference signals. Rest of them are unused. They might be used in the future. That is a standard that was left on. So when we would be learning the standards of communication, we would be seeing that we are leaving a few channels empty so that whenever we come up with a new communication standard, we might implement it there. So we have cat 5, cat 6, both can be done there. So this is the color combination you might use for straight through cable. So make sure at both end you follow this. Then we have this straight through, RJ45 crossover, RJ45 receiver. So this is what we discussed, how we normally create it. And someone might have a question like, when we were what was the size that he was measuring? So it should be a little over half inch. A little over half inch means like zero point 0.5 to zero point 0.6 inch is what you should leave so that it fixes in, and it's like the distance is even and it is really filled when. Now, yeah, like now I have seen many cables that was created by those who are novices. What they do is they keep it very long, and what happens is the end of this connector is right here. It looks good when it covers this. So zero point 0.5 to zero point 0.6, if you leave it, it will look good and it will be stronger. So that is what we have for Ethernet cables. Uh, so these are the different steps that is there. Uh, Insert cable cap with output stripper, stripping. So these are the steps that we normally do. Uh, and now we don't use a separate cutter. That cutter is implemented in my crimping tool. Those cutters are already there. So you don't need to worry about cutting. You only need to worry about that it goes up to the end so that whenever you are crimping, uh, the orange connectors that you are seeing here, uh, yes, these yellow connectors that you are seeing here, it pierces each and every wire. Now, whenever it pierces each and every wire, the right connection is being made. I hope that was clear to everyone. Now, in case we have any question, please let me know. Now, in case we don't have any questions, we might this is a client server model which we have already covered, but we might talk about it. And in case anyone has any question, just let me know. We can take those questions from the client server model. So before we discuss the client server model, we had discussed we discussed what a client is and what a server is. Can anyone remind me what a client is and what a server is? What does a client do? It raises requests. It raises requests. It asks for uh, some resources, and that resources are being processed by my server. Uh, like uh, mm, Processes those requests. Uh, like yes. Now we can have we talked about servers. What servers are exactly? Server is a program or device that provides services. Yes, it processes those requests or provide those services. Now we can have multiple types of servers. The first can be our application server. Now, anyone having any idea what application server is and anything about application server? The different types of server, in case anyone can help me with. Fine. So we can have application server, we can have file server, we can have mail server. Uh, After mail server, we might have web server, we might have database server, and we can have a lot many types of server, name server, print server. Uh, we can have a lot of. So let us stick to these servers and try to understand what they are and what is the function they are providing. So can anyone help me understand what, and in case anyone has any questions on any other kind of server, just let me know. So what do you think an application server can be? Uh, that is Pooja. Hmm, fine. So then we also have something called web server. What do you think that would be? Hmm, okay, I agree. But then how do you differentiate between an application and a web server? Raju, would you like to say something? Web process. Okay.
Web application server.
Raju, if you are speaking, uh, I don't know. I can't hear you. Fine. So Pooja says something. Web process. Web server stores, processes, deliver web pages to the client. Really good. Web server is perfectly fine when you are hosting your website, your web pages, and those web pages are being transferred or provided to the client. That is done via a web server. Now, in case we talk about application server, so first we need to understand we can have web applications. Now, those web applications now we have mobile applications now which are not only on mobile platform but they are also a kind of web applications. Now those applications mhm. Now in case we talk about an application server, what it does is uh, as a user I am connecting to a application and I don't need to store that on my device. Right. So, an example, if we want to say, now suppose I am using this application that is Microsoft Word. So, I don't need to store this document or this application on my computer. I can still go and use it. I can continue using it without storing it on my device, without downloading any data on my device. So that is an application server. I hope that was a little clear. In case I talk about this mail, I can also down like we previously also we had those. No, let us not talk about mails. Now, in case we talk about an application that is Facebook, I don't need to download this data on my device and still continue to use it. These application servers would be using storing a lot of data. So every user is using that application on uh, in the interface, and that interface needs to collect and store all of the data. So that is what my application server is. Then we can have those FTP servers or file transfer protocol servers. Now, what these file transfer protocol or file servers would be doing, it would be allowing a transfer of files from one device to another device. So suppose I have multiple devices. These devices are connected. Suppose these all are computers and they are connected via a server. Now, what it does is it locates the location of a particular file. Then it brings it to the server, and now once the server has it, it provides you with that particular kind of file. Now, what according to you would be a mail server? One particular example would be the Outlook. We have previously had that Outlook. Yes, someone has said something. Mail server is used to send and receive mail. Particular in case we talk about the protocols that are used. So SMTP is the most widely used protocol that was used previously. Now we have IMAP and POP3 as well. So these are the different protocols that might be used. In case we talk about the file server, FTP server is what we are normally, FTP is what we are using as our protocol. So we previously had that application, the Outlook application that was using the mail server, where you are storing your mails are being stored and it is being delivered. So that is my mail server. Now then we have those web servers which are used to store your web pages and deliver it to the clients whenever they ask for it. Then we can have print server. So these print servers, what they do is they connect to the computers uh, who want to print through those servers. Now we have multiple computers, and these servers are connected to the different devices that are there, the different computers that are there, and they allow those devices to print, use the printer through them, and that can be used a single printer might be used for multiple users. So that is my print server. Then we can have database servers. So database servers are the difference between database servers would be something like an application server having a huge storage. We talked about application server, that every application server is storing a lot of data from all the users. So this again, this database server would also be having a huge database, a huge storage is needed. So what happens is the whole organization, the whole company is storing all its data on this database server. Uh, and they can be whenever any of the devices or any of the computers they need a particular data or a database, they would connect to my database server and they can fetch it from there. And uh, in the coming days you would be learning about the different database structures that we might have. So uh, you can use it for structured and unstructured databases also. So it is not that it would only process structured data. No, we can also go for unstructured data as well. So they can be that can be the different databases, different servers that we might be having. So any questions, anyone? Now I hope that was something which network server types explained. Great. So that would be good. You might go for it. Now, in case we talk about the client server model, this is what we have already seen. You have a server, and to this server, multiple devices are connected. Now, let us make it a printer. Now, this can be taken to be a print server, or uh, you can understand it as you want. Now, this is normally a client server architecture. All these users are our clients, and this is the server. Now, in case you want to implement the SMTP on your server, what happens is all these can use a mail service, and I send a mail. This goes to this server, and this server stores all those mails. Now, those mails might be or might not be downloaded on your computer, and still you would be able to use it. So that is how my mail server works. Now, suppose I am using it as a application server. Now, what happens is I store that particular application here. You want to use that application? Fine. You don't use your own process, you don't use your own device. You simply use it as a browser, and using that browser you log into this server, and you are using the server processing for using that application. You don't download the application data here. You don't download the application. You keep the application on the server, and you use your that application from this browser on this computer. Now, everything is being used of the server, and you are using only the connectivity of your device. So that is how an application server works. Now, suppose I am having it as a web server. Now, my web pages are here. You are asking me for page 3, I do give it. You want me home page, I give it to you. You want the contact us page, I give it to you. So this is how it can function as a web server. Then in case you want a print server, every device is connected. Now this needs a print. You store the print elements here, and this will help you to print. So in case I am using it as a database server, now what happens is I have some data, I put it here. I have some data, I put it here. Now he needs some data, he takes it. So this is how your database server would process. Now I hope that was you were able to understand. Against this model, we have a peer-to-peer model. Now, what happens in a peer-to-peer model is this is what we have already seen, but still let us go for it again and again. So this is how we all are connected. Each device is connected to the other device. Sorry. Yes. So each device, whenever it needs anything from this, it will communicate on this channel. So we create a channel. Normally, it is a physical channel, but at times we might use logical channels between two devices as well, depending upon how good our architecture is or how good we are with it. So we can have it. So that is my peer-to-peer model. Now, any questions still here? Okay, fine. So that brings us to our uh, hmm, hmm, servers, okay, peer-to-peer network. Then we have a term called node. Uh, I hope everyone understand the term node. Now, how do you define a node? Someone has said something. Node PC, okay. Now, in case I speak about computer network, I would say nodes are not only our computers. They can be said to be any of the network devices that is closing in. So it can basically, we have the PC as our node. It can be our modems as well. We can have our printers as well as our nodes. Uh, Most of the devices that are getting an IP address, a separate IP address, can be said to be our nodes. Uh, in cases, we might consider switches also to our nodes. We can have bridges as our nodes too. We can have hubs as our nodes too. So all the devices that are having a separate IP address can be said to be a node. We could come to it and try to any system or device connected to a network. So most of them that are connected and they have a separate IP address can be said to be a node. Uh, now, mm, the next question comes in: what does a node do? What nodes are all about and what nodes are supposed to do. So, what do you think these nodes are doing? So, any of these devices that we are talking about, they might send or receive data. That is the purpose. Either send or receive. Someone has added in something, I believe. Nodes create, receive, and communicate data. Uh, fine. Fine that we can say that, but it is better. I would prefer sending or reception of data. They can send data, they can receive data. So, like switches, they receive data. Mm, Uh, Printers, they cannot send, they can only receive. So, that is the sole purpose of it. And again, we talked about yes. Uh, Yep. I believe that brings us to another concept that is called the topologies. So I hope most of you have seen and have a basic understanding what a network topology is. So topology, sorry, topology. We have something called the network topology. So anyone has an idea what we understand by network topology? How would you define network topology or anything you understand about it? Create IT lab by using topology. Fine. Someone is trying to write something. Let us wait. That seems to be Lizzie is writing something. Bus ring star mesh hybrid good. Arrangement of elements of the network. Fine, great. Thank you, Lizzie. So I would say the physical connection. The physical connection of the nodes. Better to say devices. I talked about nodes right before network topology. Since we are going to use this term nodes here, physical and logical structure. Uh, Fine, logical would come in a bit later. Right now, it is just the physical connection. Now, how you are connecting it physically, or how you are uh, creating a physical network. We can have multiple types of this arrangement. So Pooja has told us a few things. Bus, ring, star, mesh, hybrid. The first is my bus topology. Bus topology. Now, bus topology is something like you have this cable or the bus, and all the nodes are connected to it. All the devices are connected to it. We might implement token ring here. Oh, I am arranging it very well since I cannot make good drawings, so at least let me make it look good. So this is how you are creating a bus topology. All these devices are connected in a series, right? You are connecting it, all the devices in a series. So that is my bus topology, where all the nodes are connected directly to your cable. Backbone cable. In bus, all nodes are connected with, yes, with the. That brings us to another topology that was that Pooja told us. That was our ring topology. Fine. So let us ring. Ring would be followed by star, mesh, and hybrid. Okay. Ring, star, mesh, and hybrid. So these would be the five topologies that we might have. So let us go for our ring topology. A ring topology would be, now in case anyone wants data from the other, he can access it. Like most probably we would be using a ring yeah, like ring token here. And that ring token, what happens is we will see that at a later stage, since we would be learning all those. So collecting data, it would be really very easy here. Like in case you want to receive data, that would be easy. But the problem happens when we are going to move back and forth. So what happens normally is a token remains running on this bus throughout. And now in case this computer needs some data, it puts its request on that token bus, and that token bus goes up to here. And now what happens is this does not recognizes that token. So again, it starts from the beginning, and then this has the token. No, this doesn't recognize. Now suppose this recognize. Now what happens is it takes that token and it retains it and it puts its data here, and that is being carried. Now again, this recognizes, and this recognizes that this is the data that I need. We will talk about the token ring token, later. Next is my ring. Ring is implemented physically like this. Connected in a loop or a ring. Yes, we create a loop. Let me use 5 computers. Now what happens is this computer raises a request. Uh, Normally we might use any technology we use. Now that request raised here will go through the complete network. Now suppose this recognizes the request that this request was made for me. So this will stop the request and it will put the data or the resource on the bus, and that will really receive that will be received by my requester or the computer that asked for that request. Now once we have this request, what happens is that will be fine. The problem with this is, in case suppose one of the devices does not work, the complete network goes for a toss. The data, our data will move till here, and now it is stopped. Suppose this cable goes for a toss, the complete topology fails. So I hope you guys understood. Uh, Here also we normally go for token ring, but we might implement other technologies as well. Now, to overcome this problem of one of the devices or one of the cables failing, we came up with this mesh topology. The mesh topology would be similar to my ring. So this is my mesh. This is my different computers. I would be using 5 computers. Now, what I do is I will connect each and every device to the other device. Now, each and every device is connected together. Now, suppose this device fails. Still, the communication does not stop. We might take the other route. Like, suppose it stops here. What I can do is I can go for another loop so that the communication does not stop. The problem would be yes, data would be sent through another route. And since each and every computer is connected or each and every node is connected together, now this comes up with a request. This request is broadcasted throughout the network. Now, the broadcast of the request is not supposed accepted by this. They will drop all the requests. No, those who are not supposed to have that data, they will drop that request. This will flag on, and that once they have flagged, it receives the request and then it sends it back the data. So this is how this mesh topology works. The problem arises is maintaining this network is really very tough. Now this much of cable, it would be very what do you call? It would be very bulky. A lot of wire is needed, and that will create the problem. Right. The next is my star topology. Now, star topology would be something like this. You have a central system. Now, this central system would be connected to the other systems. You can connect as many to the central system. So this would be my star topology. So server or any, someone has said anything. All devices are connected to a central system. So this central system that might be a server or might be a switch or might be any of the devices in case we are using a server. So a request raised is processed by this server, or in case it is a switch or a hub, a request raised reaches this hub, and from this hub it is broadcasted to all the systems. And now that system that accepts, that will raise a flag, raise an acknowledgement, and that acknowledgement will make the hub or the switch to stop other operations and receive this data and then send it back. And once the data is received by this device, the requester, it will send an acknowledgement, and that acknowledgement will be there till this receives the acknowledgement, and the acknowledgement is sent back. And then once it receives the acknowledgement, that flag would be unflagged. And then once it is unflagged, this switch or this hub would be idle, like it is free. It can process any other request. Now that is my star topology. Then we have the hybrid topology. Can anyone help me know what do you how you will define this hybrid topology? Yep, guys, please. How you will define this hybrid topology? Star all devices connected to a central device like hub or switch. Yes, really good. Data sent another route. ठीक mix up of various topology. Star bus topology. I don't know what combination of bus start free. Okay. So I am implementing a ring and a star topology on this bus topology. So that can be an example of my hybrid topology. I am also implementing suppose mesh here. So it depends upon what kind of thing you are working on. So this might be taken to be a hybrid topology. Now, anyone having any question till here? In that case, it is already 12. We might wind up for the day. Now, can anyone confirm me the attendances of the different NSTIs that were present?